How are you, our students? We will speak with you today on the electric cells. Electric cells are a product of an oxidation reduction reaction. Oxidation reduction reactions may be spontaneous or may be non-spontaneous. If it is spontaneous, then we call this electric cell a galvanic cell. If it is non-spontaneous, we called it an electrolytic cell. There is general notices in all kinds of cells, which are the anode, the cathode, the electrolyte. The anode is the half cell which an oxidation process happened to it. There is an accumulation of the electrons and transferring of the electrons from the cathode or traveling from the anode to the cathode. And what is the cathode? The cathode is the electrode or the half cell which a reduction process happened to it. So anode means oxidation or at which oxidation process happened to it, and cathode means a reduction process happened to this electrode. So these cells denotes that the transferring of electron from the anode to the cathode, from the anode to the cathode in the outer wire, here, okay, and the movement of electrolyte ions inside, anions toward the anode and cations toward the cathode. Anions negative ions and cations positive ions. So the negative ions go to the anode and the positive cations go to the cathode. Now the electric current arises from the oxidation which happened on the anode. Oxidation happened to the anode, leaving electrons. These electrons go to the cathode, okay, and here anions go to the anode and cations go to the cathode. Now the electrolyte, which is here, may be a molten substance or an aqueous solution of salts, acids, alkalis, or molten salts, or the oxides that conduct electric current. The electric cells can be classified into galvanic cells and electrolytic cells. Galvanic cells is the electric cells which you can obtain electric current from a spontaneous oxidation reduction reaction. So we have a chemical energy which is transferred or converted into an electric energy. Electrolytic cell here is the electric cell which converts or which transfers the electric current or electric energy from an outer source into a chemical energy. So there is a spontaneous process here in the galvanic cell which contain or includes the transferring of chemical energy into electric energy. Also here there is a conversion from the electric energy into chemical energy from an external source. External source is furnished to the cell and it converts the electric energy from the outer source into chemical energy. Now we will take the galvanic cells. At first, galvanic cells is the electric cells which converts the chemical energy into electric energy. We'll take a very small and simple example of reaction. Zinc reacts with copper sulfate to form zinc sulfate and copper. This reaction is an exothermic reaction, delta H minus 217.6 kilojoule per mole. So if we want to make an electric cell from this reaction, we have to make a separation between the oxidation process and the reduction process in two separate containers, like this. Container which contains the oxidation reaction and another container containing the reduction reaction. The one has the oxidation reaction is the anode, and the one at which the reduction process happen is the cathode. Okay, we connect between the two electrodes here with an outer wire, and between the two solution with a salt bridge. Salt bridge connects the two solution of the two half cells, and the outer wire connects between the two electrodes. Here the porous septum connects between the two electrolytes. So the galvanic cell in its simplest form is Daniell cell. Daniell cell consists of zinc half cell at which oxidation process happen, and copper half cell at which the reduction process happen. Between them there is a salt bridge, and it is very important to the reaction to happen and continue and continual electric current to be in the cell. So what is the zinc half cell and what is the copper half cell? The zinc half cell is a container contains zinc ions with a concentration of the zinc equals 1 molar. Any salt of the zinc, like zinc sulfate, like for example, and this container contains a zinc sheet or a zinc electrode dipped partially in the solution of zinc salt. On the other hand, the standard copper half cell makes or includes a container which contains a copper ions or a copper salt. Its solution concentration equals 1 molar, and for example it is a copper 2 sulfate. Copper sheet or copper electrode dipped in this solution partially, and consists also this electric cell of a inverted glass shaped tube. A solution of sodium sulfate is put in it in a gelatinous substance. These two solutions cannot conduct electricity. The solution of zinc and zinc electrode cannot make any electricity. Copper electrode or copper half cell cannot make electricity unless both of them are connected together. Electrodes connected together and solutions connected together. How we make it? We make a galvanic cell, or a very simplest galvanic cell, which is the Daniell cell. Daniell cell is composed of the anode, which is the zinc half cell dipped, or zinc electrode dipped in a zinc solution, and also copper half cell, which consists of a copper ions or a copper salt like copper sulfate, and in it there is a copper sheet or copper electrode is dipped partially in this half cell. So we connect the two electrodes by electric wire, and the two solutions is connected or are connected by the salt bridge. Salt bridge contains sodium sulfate solution. So what happens by connecting the anode and the cathode? What happens really is the oxidation of zinc here in the solution. So the concentration of zinc here increases by time and leaves the electrons here on this electrode, so it is a negative electrode, and these electrons travel in the outer wire to the cathode. The cathode here accepts electron as it is the positive electrode, and ions, copper ions in the solution transferred or deposited on the electrode of copper. This is what happened. Oxidation of zinc ions or oxidation of the zinc atoms into zinc ions, dissolving it in the solution, and its dissolution in the solution of zinc sulfate, and the deposition of copper ions into copper atoms in the copper electrode in the galvanic cell. So if this process continues for a long time, zinc ions will increase in the zinc half cell solution, and copper ions will decrease in the copper half cell solution. As a result of this, zinc ions increase in the zinc half cell, and copper sulfate ion increase in the copper half cell. So we see that zinc increase here and sulfate increase here. So if this operation continue, the electric current will stop. The electric current here will stop. So how can we make this electric current not to stop flowing? We put here the salt bridge. This salt bridge will neutralize the excess ions in the anode electrode, anode half cell, and the cathode half cell. How? Zinc here increase in the zinc half cell. Okay, so sulfate go toward the zinc half cell to neutralize the excess zinc ion, and sulfate here increase. So sodium ions go toward the copper half cell to neutralize excess sulfate in it. Okay, so this is what happened. In the anode half cell, zinc is oxidized from the electrode and go into its solution as a zinc ions, leaves 2 electrons. These 2 electrons go in the outer wire, and go into the cathode half cell to reduce the copper cations with these 2 electrons, or with these electrons, and it deposited the copper from ion to copper atoms in the cathode. So the overall reaction is the oxidation of zinc into zinc ions and the reduction of copper ions in the solution into copper atoms, which deposit on the copper electrode. So we see that after a time from this process, the anode electrode, its mass will decrease, and the cathode electrode copper, its mass will increase. Zinc ion will increase in the zinc half cell, and sulfate ion or anion will increase in the copper half cell or the cathode. So we have to neutralize, as we have said, to neutralize the excess zinc and the excess sulfate. How can we make that? Zinc increase in the zinc half cell and neutralized with sulfate, which is from the salt bridge, to make zinc sulfate. Cations here or anions here increase in the copper half cell, sulfate anion. So the sodium ions from the salt bridge go to the cathode half cell to neutralize excess sulfate anion and forms sodium sulfate. So after studying this galvanic cell and Daniell cell, we have to go to the questions. The first question is the occurring reaction here in the galvanic cell. Cobalt +2 plus iron gives cobalt and iron +2, which we call ferrous ions. So what happened, or which of the following express the reaction? We see here in this reaction cobalt reduced from cobalt ions into cobalt 0 solid, and the oxidation of iron from elemental iron 0 2 ferrous iron positive 2. So the first choice, cobalt ions oxidized. Is it true? Cobalt ion oxidized. We see here cobalt reduced. The second choice, B, cobalt ions reduced. It is reduced, yes. Cobalt ions is reduced from positive 2 into 0 here. As a result of losing electrons, oxidations means, or reduction means, gaining electrons. Here the choice is cobalt ions reduced by losing electron. Reduction is gaining electrons, so also it is false. Iron atoms are oxidized, yes. We see that iron is oxidized from iron atom to iron positive 2. So the correct one is C. Another question. So the following ionic equation represents the reaction occurring in galvanic cell. Barium plus zinc, barium positive 2, zinc 0. So we see that barium is oxidized from barium 0 to barium positive 2, and zinc reduced from zinc positive 2 into zinc 0. So which of the following shows what happens in this? What happens on operating the cell? A, each barium atom loses 2 electrons. Yes, sure. And zinc acquires 2 electrons. Yes, it is correct. So the correct is A. Okay, on this point we will finish our video. Keep with us, we'll explain everything. We'll make questions, a lot of questions after explaining electrochemistry. We give all the bank questions, the information bank data, or the question of al-mu'asir, of everything, questions in every source we will answer after explaining the electrochemistry. So keep with us. Any questions, any comments are welcomed. With you, Mr. Hisham Chemistry. Thank you.